This video is going to be on section 2.2a. I can solve two-step equations. So we're going to use the same inverse operations that we did in the last section, but what's really important for two-step equations is remembering the order that you do it in, and it's going to be backwards order of operations. So if you think of PEMDAS or however you remember order of operations, it's going to be backwards for solving equations. So the very first thing you're always going to undo is addition and subtraction. And then after that, you're going to undo multiplication and division. And then after that, you're going to undo exponents. So then let's do some examples where we go over this and we use this. For example 1, let's do 16 equals 5x minus 9. And I usually start by drawing a line down my equal sign to remind me that whatever I do on one half of the equal sign, I have to do on the other half, or one half of the equation I have to do on the other half. So, and then I also usually change the sign of the one behind before I start. So first thing we undo is addition and subtraction. To undo a negative 9, adding a negative 9, I have to add a positive 9. And then if I do it on this side of the equal sign, I have to do it on this side of the equal sign. 16 plus 9 is 25. And then I have 5x left on this side. This became 0, so I don't need to write anything. Now I need to undo multiplication. That's my step 2. So I'm going to, the opposite of multiplying by 5 is dividing by 5. 5 divided by 5 is 1. So I get x equals 25 divided by 5 is 5. And then remember, we can check our work by plugging 5 back in for x. So 16 equals 5 times 5 minus 9. If this is true, then we did it correctly. If it's not true, then we did it incorrectly. 5 times 5 is 25. 25 minus 9 is 16. So I got 16 equals 16. That's true. So we must have done it correctly. For example 2, let's do 15 minus w over 4 equals 28. And again, I'm going to draw the line down my equal sign to start. And then I always change the sign of the one behind to before. So again, step 1 is to undo addition and subtraction. I have a positive 15 here. To undo that, I'm going to subtract 15 from both sides. So now I have, this becomes 0. So I have negative w over 4 equals 28 divided by 15 would be 13. Sorry, 28 minus 15. I don't know why I said divided. Then I need to get rid of this 4, and I want to get rid of this 4 and this negative in one step. The opposite of dividing by 4 is multiplying by 4. So I'm going to multiply by 4 on both sides. And then I want to get rid of the negative also, so I'm going to multiply by negative 4 on both sides, because then it doesn't look quite right. Now we know it's multiplication. Because then a negative times a negative will be a positive, and I'll just be left over with w. So then 4 divided by negative 4 is 1, so I have 1w. 13 times negative 4 is negative 52. So we get w equals negative 52. And then again, we can check our work by doing 15 minus 52 minus negative 52 over 4. Does that equal 28? I would change the sign of the one behind. 52 divided by 4 is 13. 15 plus 13 does equal 28, so we did this correctly. Okay, let's do a little bit of a different kind of example for number 3. Let's do 4 equals 3 plus w cubed. So I'll start by drawing my line down the equal sign. And then I don't have any subtraction to change to addition. First thing I'm going to do is undo addition. So I subtract 3, 4 minus 3 is 1, and then 3 minus 3 is 0, so all I have left on this side is w cubed. And then I go on to step 2, which is undo multiplication and division, but I don't have any, so I go on to step 3, undo exponents. To undo cubing, I take the cube root of both sides, so I get w equals 1. And then I can check my work by plugging it back in. So does 4 equal 3 plus 1 cubed? I have to do 1 cubed first. 1 times 1 times 1 is 1. 3 plus 1. Does that equal 4? Yes, it does. So we know we've done that one correctly. Okay, and then our last example, example 4. Let's do n plus 3 divided by 8 equals negative 4. Okay, this one is important because it's an exception from the other problems, because this division line groups the n plus 3 together, kind of like parentheses. So since the n plus 3 is, or the n and the plus 3 are grouped together, I can't undo that first, even though I normally undo addition first. I have to get rid of this 8 on the bottom before I can get rid of this plus 3, because it's grouped with the n. So to undo dividing by 8, I'm going to multiply by 8 on both sides. 8 divided by 8 is 1, so I have n plus 3 equals negative 4 times 8 is negative 32. And now I can get rid of that plus 3, so I'm going to subtract 3 from both sides. So I get n equals negative 35. Then I should check my work by plugging it back in. So I'm going to do negative 35 plus 3 divided by 8. Does that equal negative 4? So let's see. Negative 35 plus 3 is negative 32. Negative 32 divided by 8 is negative 4. So I got negative 4 equals negative 4. That's true, so I must have done this problem correctly.